Good evening, everyone. As Maddie said, I'm Sean Birkel, and I'm an assistant professor at the University of Maine with a joint appointment between the Climate Change Institute and Cooperative Extension. I'm also the Maine State Climatologist. A lot of syllables to get through with my title and affiliations. And as Maddie said, today I'll be sharing an overview of climate change in Maine, trends in precipitation and temperature, and how that relates to the growing season and ultimately to gardening and agriculture. And of course, Caleb will focus on the gardening impacts. And first, I just wanted to mention what I do in my role, where I have a joint position at the university. I'm part researcher and also part climate services specialist. My state climatologist role spans both, but is primarily directed towards providing climate and weather data and information, working with Maine stakeholders to help inform decision making. And as a researcher, I study large-scale climate variability over a broad range of timescales, and I develop climate data products. And so now moving on to the talk outline. First, I'll go over a few highlights, a few key points on climate change in Maine. Show you temperature and precipitation trends so you can see some of the data, and then review weather extremes that we've been experiencing in recent years, and try to provide some information as to why that's happening and what we anticipate seeing in the future based on both trends and climate models. And then I'll wrap up with some resources. So here is the outline slide. And so now here's the first summary slide with key points. Climate change in Maine, we're seeing warming across all seasons, mostly in winter. And in parentheses, you'll note that I put in fall because we've seen a lot of warming in September in particular, and that has a significant impact on the growing season. And we'll talk more about that in a little bit. An overall increase in total annual precipitation. So on average, a given year sees more precipitation than several decades ago. And the largest increases have been found in summer, but there is significant variation year to year. There's some decadal variability as well. And changes in weather patterns have produced more extremes. We've all seen heavy precipitation events, and that can impact crops, our home gardens, as well as infrastructure. And this links into an increased likelihood of weather patterns that can stall or stay in place for several days that create gradients from which we start to see extremes, as well as warming oceans. And I'll discuss more about that. We're also seeing extremes on not just weather time scale, but even on monthly or seasonal timescale extremes. For example, the growing season in 2020 across Maine ranks as the driest, and 2 years later in 2023, we saw either the first or second wettest, depending on how that's depending on the way that's measured. And also, I think pretty notably in this context, this past fall was the driest September through November period. Ranks as a flash drought, and there were growing impacts in Maine, but there's a more severe drought farther south around New York, Massachusetts, Pennsylvania. But it was just another example of an extreme event that occurred spanning about 3 months that impacted this region. So now a couple slides going over the general impacts on agriculture with obvious links to gardening. Certainly a lot of overlap there. Chill hour deficiencies as winters warm, winter injury from large temperature swings, frost freeze damage from fall spring, and I have a couple slides that show examples from recent years. And also, especially in the southern half of the state, we've all seen midwinter rain become more common, periods of runoff and erosion. Um, Now, this winter, I think we've all noticed uh, we've finally gotten some snow and some nice cold weather in stretches with temperatures staying below freezing. A big contrast from some of the recent winters. And then the last point here, warming winters, that helps facilitate an influx of pests and invasive species. Similar to in the summer, warming summers also facilitate the inward or the northward spread of pests and invasive species. And in the summertime, higher overnight low temperatures and more humid conditions during the day, higher heat indices. In part, there's a human health concern as we have to be careful working outside on days with really high heat indices. And also, in a warming climate, there's an increased, well, years in which we see dryness develop, there's more pressure for irrigation, and so for your home gardens, watering, and if you're on a well, if you're in an area that's heavily impacted by either flash drought or perhaps in 2020, if you're in an area where your well went dry, then there's obvious big impacts there. And then I have a note down here that warming, although it tends to exacerbate drying that develops, it can be balanced by precipitation surpluses. We saw that in 2023. That ranked one of the warmest winters, one of the warmest summers, excuse me. It's late in the day. I'm not as sharp as I was several hours ago. But we saw so much rain in the summer of 2023 that even though it was one of the warmest, we didn't have any drought concerns. Most areas, many areas saw that there was too much water, and that was producing challenges. And now in addition to challenges, and there can be a lot of negatives associated with climate change, but there are some beneficial aspects. Longer growing season provides more opportunity for different plant species to be grown, and new crops that may not have been tenable 30 years ago. And so that is at least, there are at least some benefits, but there are certainly many challenges. So now if we step back and take a look at statewide average conditions in terms of temperature and precipitation historically, the chart on the right here shows the annual mean statewide temperature. And this is from a data set compiled by NOAA that utilizes all available observations across the state for any given time period. And this particular data set is available for individual months and then for the year and seasons. And with this, we can see that overall, since 1895, and that's when there's widespread data collection that we could begin to synthesize. On a linear trend, there's been about a 3.5 degree Fahrenheit warming since late 1800s. So the red line, these are the individual years. The black line here is a 5-year running mean. And that has been added so you can get a sense of there is variability. There's the year-to-year variability, but then also decade or sub-decadal variability. And so when we, just in our own experiences, when we think of the average climate, one person, or many of us, may perhaps the last 10 years is what we remember most, or maybe it's what we remember when we were kids. And so this chart, it shows the year to year, the overall trend, but also the average that kind of gets at decade, sub-decade variability. And likewise for precipitation, it's an overall upward trend. Maine's climate is getting warmer and wetter, significant year-to-year variability. And embedded in that are also, we're seeing more extremes, particularly in terms of heavy precipitation, um, 2-inch, 3-inch per day events. And overall, when we project into the future, precipitation is expected to increase annually on this trend up to about 14%. And likewise, we anticipate seeing more intense heavy precipitation events. And just to backtrack to temperature, the 10 warmest years have occurred since 1998. Actually, it's 10, the 11 warmest years since 1998, because this chart doesn't include 2024. I haven't had a chance to update yet. My apologies. And the projected warming, depending on greenhouse gas emission scenario, ranges from 2 to 10 degrees Fahrenheit. And now let's take a look at the temperature annual cycle and translate those squiggly lines for temperature into something that might, but that will help bring this down to the growing season and why a 3.5 degree Fahrenheit increase, which at first 3.5 degrees Fahrenheit might not seem like much, but when we translate that into the impact on the growing season, then you can see how there's this accumulation of heat that has a big impact. Okay, so there are 3 lines here. These are from the first 2 lines in blue and orange. Those are for the average climatology from 1901 to 2000 in blue, 100-year climatology, and a more recent climatology averaged across 2010 to 2023. And this is from the same NOAA data set that I showed in the previous slide. And then in the red line is the projected to 2050. So 25 years from now, in a way, right around the corner. And as you can see, it on the x-axis are the individual months. And now we can step through this. And the key point that I want to make is that as the climate warms, there's a relative shift on this chart where if we now look at different baselines, say we take the 32 Fahrenheit, this is of course really critical in terms of whether precipitation is frozen or melted. And we can use this as a general proxy for when we look at the average temperature, get a sense for when winter ends in terms of when, in general, when we expect the snow to start melting versus start accumulating. And we find that there's been about a 2-week lengthening of the warm season, and likewise about a 2-week shortening of the cold season. And now we can also use another baseline. 50 degrees Fahrenheit is fairly close to about what we might consider for the growing season. And we find that there's been a little bit more of a lengthening between these 2 climate periods, in particular in late summer and into fall, and especially during September. And I think we've all found, especially those of us who have been in Maine since, who either grew up in Maine or have been in Maine since the 80s or 90s, there aren't quite as many chilly mornings as there used to be. And it's shown in the data. We can look at daily data, but that's been one of the biggest changes is the extension of the warm season into September, having a big impact on the growing season. And projecting into the future, 25 years ahead, we may see up to 3 weeks or more in terms of a lengthening of the growing season. And then, as you may have already read on this chart, just a few other notes in terms of in the spring, decreasing snowpack, earlier snow melt, spring runoff, and lake ice out, all factors that are impacted with an earlier spring. and then in the fall, later onset of snowfall, and later lake ice on. So it impacts um, uh, beyond just the growing season, but impacting snow and ice cover in the winter. And so now, in terms of plant hardiness zones, uh, this map is from the Maine Climate Council's Science and Technical Subcommittee report, and it was released earlier in 2024, modified from a previous paper that was published. But it shows 3 climate periods. Average conditions between 1991 and 2020, centered on about 2005, and for 2050, and then for 2085, something towards the end of the century. And the major take home here is that if we focus on one point, so in this case, Monmouth, we can see how with these different periods, how the contours shift. And to really boil this down, the plant hardiness zones, and this is based on the extreme minimum temperature, by late century, the hardiness zones in Monmouth would be more comparable to what we would find in eastern Pennsylvania, New Jersey, perhaps Long Island. And then when we look at, I thought I was going to put a slide with the growing season, but this is consistent with the increased length of the growing season between first last spring frost and first fall frost. And so overall, when we peer into the future, depending on greenhouse gas emission scenario, Monmouth or the southern half of Maine, that climate will be more comparable to say Connecticut to New Jersey, on that order. And so now I mentioned season extremes. I alluded to it, the drought in 2020 versus the very wet conditions in 2023. And I wanted to now to say a few more things about the incidence of drought, because we have seen, since 2016, we've seen several seasons in which various parts of the state had anywhere from moderate to extreme drought, with 2020 really being the standout year. Historically, drought is relatively common in Maine in the Northeast, and that's short-term drought. So drought that might persist up to about 6 months, and then there's very commonly a quick return to wet conditions. And the studies available to date are uncertain as to whether or not we'll see more or fewer droughts. But in a warmer climate, especially with a longer warm season extending into the fall, with higher temperatures, if weather patterns produce a drought, then the warmer climate will tend to exacerbate that. And it is possible, and we have seen some recent evidence that this could be the case, is that in the future we may see more short-term intense dry periods. And the most recent example, it would be this past fall. But at the time being, there's still some uncertainty whether or not these droughts will become more or less common. And I added this just to give you a sense of, since 2019 through 2022, this is where we saw an increased incidence of drought across the state. And then just to highlight, September of 2020, there was drought disaster declarations in Aroostook County, as well as in York County in association with southern New Hampshire. And but you can see that it wasn't there wasn't drought everywhere across Maine. It was varied by region, and some years had some drought carryover. And now it's interesting, this year the weather pattern has become quite active, and actually in a 10-day forecast, when I checked this afternoon, there are four storms in a 10-day forecast that looks like they might all bring snow. So this will really help because we started out the winter with drought signal from that very dry, from that record dry fall, and so will that this snowfall will contribute to in the springtime replenishing groundwater deficits. So now to get into um, more along the lines of extreme weather, why we're seeing more extremes, why we're seeing more heavy precipitation events. It links to what we call an intensification of the hydrologic cycle. The hydrologic cycle just refers to the transfer of water from the oceans into the atmosphere through evaporation, and then eventually to cloud formation, and where precipitation can then fall over land into lakes and rivers and back to the ocean. In a warmer climate, this process intensifies, kind of like turning the heat up on a pot of water. And with this intensification, that's part of what's driving these extremes. And in particular, the enhanced evaporation places more moisture in the atmosphere, and so there's more moisture for which a storm system can produce rainfall. And though there's a statistic here, the water holding capacity of air increases by about 7% for every 1.8 degree Fahrenheit amount of warming. Now, there's also changes in atmospheric circulation, changes in and these changes can be subtle, but impacts on the circulation of the jet stream, that in a warmer climate, there becomes a greater likelihood of what we call blocking patterns developing that can produce a heat wave or a cold wave, a pattern that sets in place for several days that enables extremes to build up. And so it's both the warming ocean surface temperatures, more moisture being entrained in the atmosphere, but also changes in atmospheric circulation that are contributing to more extremes. Now, in terms of rainfall, the Northeast region has seen the largest increase of 99th percentile precipitation events. Or those are the 1% of precipitation events, the top ranking in terms of totals. It just as an example, here's from October 2022. There's a 5-inch rainfall event that occurred overnight between October 14 and 15. This 5-inch event was recorded at the Bangor International Airport. But you can see on this storm accumulation map here, a large area of the state saw more than 3 inches of rain that produced a lot of localized flooding, washed out roads, and a number of cases in recent years where these heavy precipitation events have had big impact in some areas, as well as on December 18. And I have a slide on the December 18, 2023 storm coming up. A couple other extremes, and many of you may remember this one. In 2012, the third week of March, between March 22nd and 23rd, there was temperatures across about 2/3 of the state reached into the low 80s. And in at Farmington, for example, the daily maximum temperature was set by 17 degrees Fahrenheit. Normally, we see high temperature records being set by 1 degree, maybe 2 degrees. So this was an exceptional event, and there isn't anything that matches it in the historical record. This was now almost 13 years ago, but this occurred because there was a blocking high pressure that had developed over the central part of the continent, and then it slowly moved to the east. And while that pattern sat there, I was drawing up heat and humidity off the Gulf of Mexico, and you can see this temperature anomaly map here. And now over Alaska, you can see very cold conditions. So there's the buildup of extremes. One place is getting buildup of heat, another place getting a buildup of cold. And then when a pattern like this breaks, we often get a powerful storm system. But there's my oldest son back in 2012. Unfortunately, the snow was not very good for sledding that year. Now for a more recent example, in 2023, we saw a series of extremes, and then there was a lot of press about worldwide the record warm temperatures on a global average. And in Maine, that very wet summer that we had, that was associated with these blocking patterns. And in particular, in May, there was a strong ridge of warm air blocked over Western Canada, northwestern Canada. And downstream of that was a trough. And this particular event here, it was exceptional for going back to 1940. It was the record strong ridging event, and it was a pattern that kept persisting and kept reforming for a few weeks. Well, you may recall the May 18 freeze event in 2023. That was associated with this large-scale pattern where there was ridging over the west and a deep plunging cold trough developed in the east, and that produced this very late season frost. And I did an analysis with the Bangor temperature data, and I found that there was an event comparable to that back in the 1950s. So this was an extreme. And temperature in Old Town got down to about 22 degrees Fahrenheit for about 45 minutes towards the end of the morning. So that was definitely a freeze, not just a frost. Now, just a couple more slides. Sou'easter storms. Last year, December 18, and then January 10, January 13, those storms all began as nor'easters traveling up the East Coast, but then veered north into Quebec. And the December 18 storm in particular, there's a blocked high pressure off Newfoundland. And with the high circulating clockwise and the low circulating counterclockwise, that brought a enormous plume of moisture up and heat. The temperature got into the 50s. And on this map here, the storm total precip accumulation, much of the state saw over 2 inches of rain. Parts of Western Maine saw over 4 inches of rain, and even over 6 inches in some isolated areas. A huge amount of damage. I think we were all impacted by that storm in one way or another, and the worst flooding on the Kennebec and Androscoggin in about 40 years. Studies to date, and here's a preliminary analysis from the National Weather Service, examining these sou'easter events. There does not yet seem to be a trend, so we're unsure whether or not these events are increasing, although locally in the past several years it seems like there is an uptick. But we need to evaluate more station data statewide, try to get as many long-term wind records as are available, and to really better understand the trends. But what we can say, and this is based on using climate models to project changes in the storm track, it's uncertain whether or not these powerful extratropical cyclones will become more frequent or not. But climate models are consistent in that storms are becoming more intense and producing more rainfall. And so as the climate warms, these will continue to be an increasing concern in terms of when these storms happen. They'll be more impactful. And then I'd like to wrap this up with just to note the Maine Climate Office is available if you're interested in Maine temperature and precipitation data, either from daily records or monthly records, as well as other resources such as weather forecasts, NOAA climate outlook maps for 6 to 10 day, 8 to 14 day, as well as seasonal. And there's also a page where I have the estimated first freeze and last freeze maps for the U.S. and a link to a tool where you can pick from station data, you can calculate what the historical frost dates are. There are other resources on here, and I also want to mention that the University of Maine recently received congressional funding to develop a new statewide mesonet, a weather station network that will help to fill in gaps between stations that are available through NOAA and the National Weather Service. We're working with the National Weather Service as well as Maine Forest Service to identify locations. And the primary goal is to help, um, is for this to be to the benefit of agriculture and forestry, more high quality, highly maintained station data that includes soil temperature and moisture probes. And these data will become all accessible through the Maine Climate Office website, and we'll be developing data products. And so from these stations and other data streams, we'll be collecting to put into a form that everyone can easily access if you want to be able to use this for calculating growing degree days, precipitation accumulation, and other things. And I see it's 6:34. I hope I haven't gone too far over, but I'd be happy to answer any questions that you have.
So there was a question, I'll just ask this one while it's top of mind before we move to Caleb, that came in about whether there's any differentiation between patterns that are expected to happen between southern, sorry, and northern Maine or other regions in Maine.
Oh, excellent question. There's one that comes to mind right away, and that is snowfall. If we compare the snowfall data for Portland and Caribou, the going back to about 1940s, 1950s, Caribou shows an increasing trend. Portland shows a decreasing. And then when we look at the average daytime high temperature in the winter season, we find that even in a warm winter, the high temperature tends to still be below freezing in the northern half of the state. And that's not true of every season. That last year was not necessarily the case, but that is an interesting pattern that forms where it can be raining in the southern half of the state, snowing in the northern half, even though it's a warm pattern. The snow might still, the northern part of the state might still get good snow, and so I think that is that along the lines of the question.
Yeah, I think so.
Now,
Yeah.
as the climate continues to warm, northern Maine also that this particular trend will shift, but at least for the time being, there's still the northern Maine's still cold enough that we can still get really good snow years, and it seems to buck the trend sometimes.
Awesome. Thanks, Sean. I think we do have one other climate related question at the moment. Caleb, if you don't mind if Sean does that, and then we'll move to you. So Susan asks if you can say anything about changes in the Gulf Stream and potential effects on the climate in the Northeast.
Well, the Gulf of Maine is warming in part because of atmospheric patterns coupled to ocean circulation that are tending to place more warm water off the Gulf Stream into the Gulf of Maine. And there's a battle between the warm water off the Gulf Stream and cold water coming down from the Arctic along the Labrador Current, and then across Nova Scotia, the Scotian Shelf into the Gulf of Maine. So as the climate warms, less Arctic input and more very warm water input. Now, larger scale, there's an overturning circulation that there's still many questions, but there's a hypothesis that this overturning circulation could weaken, and it could paradoxically cause a cooling, especially over Europe. But that's still uncertain. It's an interesting part of the dynamics. I'm uncertain about that myself, but it is an excellent question, and the Gulf Stream influence is going to increase in the Gulf of Maine. Is long story short.
Thanks, Sean. And then I'm going to squeeze in one last question. So, any favorite books for a layperson to learn more about Maine's weather?
Excellent question. I can't think of one right off the top of my head, but I can take a look and I can ask around and see if I can find a good one.
Cool. Thanks. And we can share those out if you do come up with anything, Sean.
Okay, great. Thank you.
Thanks so much. Caleb, I'll turn it over to you.
Okay, thank you. I just briefly lost my Zoom controls, but can everybody see my slide okay? Great. I will start up the presentation. So I will try to go quick because I know in the end, if there's time, it'd be great to have more ways to can have questions about climate and our impacts. Sorry for my voice. I was just sick. But you know, a lot of what we're talking about with climate extremes are, the weather that we already get, but more, right? Like if it's been dry, maybe it stays really dry. If it's been wet, sometimes those holding patterns. So we already have we already have dry periods that affect our gardens. We already have wet periods that affect our gardens. Um, but the problem gets when we maybe cross some certain thresholds. Um, And I'm not going to go too much into temperature here, but of course, that's also true of temperature. Um, there are, of course, the bigger extreme individual events when you have really excessive rain. Maybe you get flooding and washout, or a tree that lands in your garden. Clearly, that's going to change things. But harder to really talk about for what's actionable for us. So one perspective that I am putting forward is that in terms of what we can manage in our gardens and what we can do to plan for things is to think of soil health as the foundation for your climate adaptation, because we are in a changed climate and it's continuing to change. And so if we're going to keep gardening, we got to keep adapting, right? So you can get into some different crop choices. Maybe this variety is more adaptable to different conditions than that variety, or maybe you're going to start doing perennials instead of annuals, etc., or annuals instead of perennials, or more of a mix of both. Diversification is often the cheapest insurance, right? Hopefully something is happy with whatever that year brings, particularly true for perennials. Um, and this is true for the ornamental garden as well as the eating garden, right? If you can have more plant types that favor different conditions and maybe also more areas in your gardening, in your property, whatever you're managing, that have different conditions within them, that really sandy spot is going to do a lot better in a wet year. That heavier soil spot or where the hill drains down into it is going to do a little bit better in a dry year. But outside of protected growing, like a greenhouse or a high tunnel, most of what's in your control comes back to thinking through the soil. I do want to take a step back. You notice I said adaptation. So what is climate adaptation versus mitigation? Adaptation is, adapting to the changing climate. So you're just trying to build your resilience, be more resistant to changes and different either different extremes or just different conditions. When we talk about mitigation, I know my brain often goes to like, oh, I will mitigate the harm. But when people are talking about climate, they usually, when they say climate mitigation, they actually mean reducing climate change. So that would be, reducing greenhouse gas emissions or storing carbon somehow. So that can very much be part of your gardening plan, but it's a little a little less the focus of what I'm going to talk about for adaptation versus mitigation. I do have sort of one way to think about it, like if you're adapting to the changing climate, maybe that's adding irrigation. Maybe you never had to water your garden before, you always got by. Maybe you start to do that for those dry years, or improving the drainage for those wet years. For some folks, it's an increased use of plastic, like high tunnel or something like that. Mitigating climate change might mean electrifying. So you have this is thinking often on the farm scale, like what can you electrify that so you're not burning diesel or gas, but that also is true on the home scale. Can you reduce erosion? Erosion is actually a big contributor to climate change when those organic matter rich bits of sand or dirt soil go into the waterways, then they can go anaerobic, and it's actually going to make climate change worse, as well as being a pollutant. And then maybe mitigation also means reducing your single-use plastics, so sort of slightly at odds, right? But there are things that are both. If you're increasing your soil organic matter, you're building your soil health, maybe you're incorporating more trees and shrubs, you're both adapting to the climate change and you're potentially mitigating it, hopefully mitigating some of it. So what does soil health mean? Here I am saying it's going to be the foundation. I think folks can think through what that means to themselves. In the interest of time, I will give you somebody's, I forget whose book definition, right? Uh, the capacity to support crop growth. But it's thought of in terms of good tilth, like the structure of the soil, the physical properties, how well it can hold nutrients. And then I underlined this: water infiltration, storage, and drainage, right? Because we're talking about changing temperatures. There's not much you can do about that. You can protect against cold temperatures, but you can't do much about warm temperatures except maybe make sure there's enough water so that plants can help moderate their own temperature in their own microenvironment. They do need enough water for that. Other than that, there's really only so much you can do. So we're talking about that increased precipitation as well as those dry spells. And so a healthier soil will have better infiltration of water. It'll have better storage of water and better drainage of water. And then, of course, all of this is part and parcel interacting with the success and diversity of soil life. So here's a nice prairie soil, which we unfortunately don't really have too much of here in Maine, but it sure is beautiful. And when we think of soil health, we can also boil it down into the chemical, the physical, and the biological, and then sort of their interactions. When I give like a soil fertility talk, a lot of that is talking about the chemical aspect of things, right? What nutrients are there? What's the pH? But it is all interacting with the physical aspects of the soil and the biological. When we're talking about soil health more generally, and what I'm going to focus on here a lot of is the physical and the biological and their interactions. So as we're thinking about water, what's the difference of water going into one soil versus running off of the other? When a big 2 inches in an hour rainstorm, right? Why does one soil soak it up and let it go in and drain away? And why does it sit on top of another one? Part of it is, and you'll see, we'll come back to this. You'll see that I'm manipulating this picture, the presentation it was originally from. But if we think about larger soil particles, sandier soil, there's bigger gaps. It's just physically, the bigger your circle, the more space you have in between your circles. If you have really small circles, they can pack together very tightly and have fewer pores. So when we talk about soils, we talk about soil texture. Uh, so in this picture, that one on the left, anything over 2 millimeters is gravel. We don't really count that as soil. But below that, you start to talk about a big range of sand. Coarse sand is very big, just below 2 millimeters. Fine sand is pretty small. It's just a little bit bigger than silt. Then you have silt. But if you're looking at a grain of sand at this size, clay is invisible. That's how tiny clay particles are. So then on the right side of this picture, you can see we have clay visible, but that means that the sand has to be large enough that you can't see it at all. We're talking many orders of magnitude between these different soil particle sizes. So when you talk about what kind of soil does someone have, we call it soil texture, and it's really the breakdown of these three different, not the breakdown, the makeup of these three different soil particle classes. Sand, you can see the larger circles there, silt, or clay. When we talk about these names of different soil types, the last word is what is the soil is mostly, how the soil mostly acts. So you see this one on the left, that's a loamy sand. It's more of a sand than anything else. Loam just means like a good mix of sand, silt, clay characteristics in terms of workability and things like that. So a loamy sand is a sand that's a little bit loamy. A sandy loam is a loam that's a bit sandy. Um, and it continues that way, right? And you can get divisions. Off to the right, we have a couple from the end. We have a silty clay loam. So that's a loam, but it's a clay loam, so it's more on the clay side of things, but it's also silty. So it's a silty clay loam, and there are more distinctions than this. You can, um, I grow on a fine sandy loam. So I have a loam soil that is sandy, but those sand particles are small sand particles. They're a little bit closer to silt. So look at our loamy sand on the left here. 85% sand by mass. So to make a loam soil into a sand soil that's also still loamy, you need a ton of sand. However, if we look over at our clay soil, you don't even need half of it to be clay before it is considered definitely a clay soil, not even a loamy clay. This is a clay soil. That's not to say that it's clay like a potter would use. You want like pure clay for that. But in terms of a soil that we grow on that is still somewhat useful for crop production, um, you don't even hit half of it being clay before it is dominated by these clay characteristics. And that's entirely a product of just how teeny tiny those particles are and how much they can, it's more complicated than this, but a lot of it has to do with how tightly they can pack together and how that doesn't leave as much room for air and water. There we go. So how do you determine your own soil texture? There are some tools online. The Web Soil Survey is something you can do online if you want. It's a little clunky, but it is really cool once you figure out how to use it. You can do a regular soil fertility test to the University of Maine and then pay a little bit extra for a soil texture determination, and they will tell you exactly what kind of soil you have, how much is sand, silt, and clay. Or there's a couple tests you can do on your own. So this is called the texture ribbon test. Basically, take a chunk of soil, add enough water that you can make it into a ball, like a ball of Play-Doh. Then squeeze it into a ribbon and see how far you can get that ribbon to go out there. And then, uh, there we go. There are some soil scientists break this down even further. But if you have a true clay soil, you can get it out above 50 millimeters. That's 5 centimeters. That's 2 inches. So that's like 2.5 inches before it's going to break apart and fall off of you. And you think about like a potter working true clay, you can see like it really does stick together. Whereas sandier soils, they're coarse, they're grainy, they're gonna fall right apart. So that's one way you can do it if you want to do your own soil texture. The other is called the jar test. And basically you put in a certain amount of soil, you maybe add a little detergent, not foamy detergent, but like dishwasher detergent that doesn't foam up much to break apart aggregates. And we'll talk about aggregates in a minute. Um, and you shake the heck out of it. First you measure how tall it is in the water, sorry. Then you shake the heck out of it and you set it down. And what falls in that first minute is your sand. And then the silt, anything that takes over the next 2 hours, anything that falls is your silt fraction. And then you wait until the water clears because those clay particles are so teeny tiny that they are going to take a while to settle out of that water. And that becomes your clay fraction. And you divide each fraction over your total height in the jar, and you can get a rough estimate. So the thing is, we've all got the soil texture we've got. Maybe some folks, when they're buying a new property, I absolutely did look at the soil map when I bought my place because I wanted fine sandy loam. I was gonna be okay with other soils, but it was still a selling point for me. Um, but most of us can't really change the soil we have, right? So you grow where you're planted. However, we can improve our soil structure. Um, and actually just take a step back, that not changing our soil texture. I have had people asking me, like, how much sand do I need to add? I have a clay soil, it doesn't drain well. How much sand do I need to have to add to make it, more like a loam? And the answer is because clay has such a big outsized impact, you would need to add, the amounts are staggering. It's not practical. You could make a sandy soil a little more loamy by adding clay more easily than you could make a clay soil more loamy. So we're kind of left with our soil structure. What do I mean by soil structure? Back to that graph that figure that I had cut off, those weren't actually individual soil particles. The figure on the left is showing aggregated soil. So soil particles aggregate together and they act, if you have enough small particles aggregated into a crumb like that, a crumb of aggregated soil, it is going to behave like a larger soil particle. So in this sort of figure here, the idea is these are the same types of soil. They have the same texture, but the one on the left has good soil structure. It's well aggregated. And the one on the right, those aggregates are broken up. It has poor soil health. So if you have a big rainfall event, the same soil, the same texture, one of them can accept a lot of water, the other one cannot, and it will create erosion and it will further degrade that soil health. Is one of the tough things about soil health. It takes a long time to build up, or unless you do other, compost can speed that up. But it often takes a long time to build up good soil health. You could really degrade soil health rapidly. If you've ever heard people say, don't work the soil when it's wet, that's because you can break apart those aggregates, you can compact things, you can really damage it. So when we have a nice aggregated soil, these pore spaces, these spots in between the particles, I want to say artificially, but of course this is the most natural thing in the world. They sort of artificially get larger pore spaces in that soil than you would have if it were a mistreated soil, one that's been used and abused. Um, so even these smaller particles create microaggregates. Some of those microaggregates can get aggregated together as well into what's called a macroaggregate. And it will improve your soil, right? So you can't change your soil texture usually, but and that has a lot to do with the way your soil behaves, water, uh, especially. And but just because, this type of soil behaves like this and that type of soil behaves like that, a poor soil health in this soil is down at the bottom, a good soil health in this soil is up at the top, and they're going to behave a lot more similarly than their differences in soil texture would allow them. So what is the secret to this good aggregation, this good structure, this good soil health? This is not telling all of the story, but this tells a big part of the story. Glomalin is what has been treated here to glow in this photo. And glomalin is a product from fungus. And so fungi growing in your soil are helping to actually literally hold these aggregates together. Not in this visible in this picture, but bacteria are doing the same thing with polysaccharides. In other words, your soil life, uh, if they're allowed to grow undisturbed, if they're fed, if they're cared for, essentially, they will help to create this soil health in itself. And it can be sort of a virtuous cycle over time. This is just kind of a fun way to also talk about like the quality of it. So in these two beakers in this demonstration are two different giant clumps of soil, clods of soil, essentially. And this is an aggregate stability test where there are aggregates in both of them, but like what's the quality? How healthful? It's really hard to measure these things. So this is one way to kind of look at it. It's just a visual, but you can see that the one on the left has very high aggregate stability. Same type of soil, but maybe one is from the middle of the field and one is from a grassy spot on the edge where it never gets tilled. So when the soil is really healthy, these aggregates are very stable. They're more resistant to disturbance, and that is the soil on the left is going to be much better able to take in water. It's going to hold water better, and it's going to also drain water through more freely. So getting into like our actual garden, let's start thinking through, okay, how does this work in these years when there's not enough water or these periods? Hopefully I don't have to go too far into this to say like, why do we care if there's enough water? Um, but you know, as water is being brought up the plant, it's bringing the nutrients with it. That's how plants get their nutrients is dissolved in water. And that water, the more water moving through there, some nutrient deficiencies are actually caused by really humid conditions where the plant is just not moving enough water through its leaves, and more dry air across the leaves would evaporate water away, causing more water to come up through the soil, bringing the nutrients with it. And then the water is also, you know, structural. It's what gives that plant its rigidity to hold up. And then when we remember photosynthesis, right? For every single sugar molecule, that's that C6H12O6 on the right side of that equation, you know, this is photosynthesis. You take 6 molecules of water, 6 molecules of carbon dioxide, and energy from light. You get 1 molecule of sugar and 6 molecules of oxygen. So that is, you know, it just doesn't work without the water. The other thing is that when temperatures are a lot higher, that water evaporating out of those leaves is cooling the plant. So when plants have adequate moisture supply, they can tolerate a higher temperature much more easily. Um, and the temperature around those leaves might be 10 degrees, 20 degrees cooler than the air temperature because of that evaporative cooling that's happening right there. We often use this picture to kind of demonstrate the idea that like the water in the barrel is your plant growth. That's your plant yield. And you know, what's your limiting nutrient? What's the limiting factor? And oftentimes it's water. So if you're not addressing that insufficient water, it doesn't really matter what your soil fertility is and things like that. This is a picture from my own garden. Square garden, circular irrigation, circular sprinkler. This is a corner where the sprinkler doesn't hit. if you look at the green beans, I mean, clearly you can see from the soil color, where does the water hit and where does it not hit? Um, yes, I got a few green beans off of that dry corner. But boy, howdy, was it a lot less than where the water was hitting. The plants survived. Just because you see a plant wilting, doesn't mean it won't survive. And also, just because you don't see it wilting, doesn't mean you aren't seeing reduced potential. That was a confusing way to say it. Um, what I'm saying is, you start seeing growth and yield losses before the plant shows that it's deficient in water. Um, so I don't know that those beans ever wilted once, to be honest. But this was from that dry year we had a couple of years ago. Was that 2022? They were um, they were just chronically a little bit short of water. They had enough to live, but not really enough to be fruitful and bountiful. So I like to have a rain gauge. They're super cheap. It really tells you exactly what fell right where you are. Also, if you're able to, stick your fingers in the soil frequently, touch the top part of the soil, get down to the lower parts. As our weather is less dependable, this is more and more necessary to know, like, what's the water that's actually getting down low to the bulk of the roots. If you want more water, this is apart from irrigating and adding it yourself, there's only so much you can do. Soil cover is critical. So this is, of course, thought of on a farm scale. So they're talking about tons per acre. But the green bars on this graph are water infiltration, and the red is runoff. And this is just in terms of what portion of some sort of rain event. Uh, so you can see that if you have enough on the surface, it helps to slow down. It's physically slowing down the water and giving it time to infiltrate, regardless of the soil. And that is really well demonstrated by, this is a nice NRCS soil health demonstration they like to do. Um, and they take soils of the same type, but with different cover. And you can see the jars in the back. That is showing what water has infiltrated through that soil. The the jars in the front show what water will spray down and run off the surface of that soil. And if you just look at the bare soil versus mulched soil, hardly any water infiltrated that soil if you look in the back jar, but the jar in the front is overflowed. It's full of soil. So you just had a lot of erosion losses, which is bad environmentally, but also that's your soil fertility. You've been working for that soil health and those nutrients for your crops. Um, that's why these big extreme precipitation events can be so damaging. That's one of the reasons. However, if you're just avoiding that erosion, look at just by adding mulch, hardly any water ran off that soil. Most of it infiltrated, and the amount of soil that went through that infiltration, the color of it kind of gives you a hint of some of the fertility that maybe went through it, is not nearly as bad as what ran off the first soil. Of course, if you look all the way to the right of like a well-planted sod, like a pasture, um, it all infiltrated and the water that went through is very, very clean. I mean, that is, if only we all ate grass, but that's about the best thing you can do for your soil is have long grass and tree cover. The other thing we can do for our soil, so regardless of what's on top of it, is having a higher organic matter content in the soil. So in this figure, you can see two high organic matter soils, and they're really taking in a lot more water than a low organic matter soil. And a lot of that is I don't remember this study exactly, but I'm going to go out on a limb and say a lot of that is that soil health, that structure that is attributed to the organic matter keeping those microbes happy and helping create a better structure for water to go in the soil. Okay, now thinking through too much water. This is another one of my garden areas. This was 2023, really, really heavy rain events in the spring. This whole area is getting prepped anyway, but you can see you can't, a plant is not going to be happy in that. If I work in that soil when it's that wet, it's going to get damaged. And also there's erosion happening in the back. There's going to be some runoff there. I'm losing some nutrients. I'm losing some soil. I've since put in a little culvert area. Part of this is also there's the soil itself, and then there's your surrounding landscape. Solar panels, those are not infiltrating water. Those are shedding it, and it's going to that same spot. You can't see in this picture, but there's a big parking area off to the other side. That was also draining over here. So in terms of my adaptation, I've adjusted some of those things to try to divert some of that water that's coming from impervious surfaces. As we think of our soil, again, on the left here, our mineral matter, our organic matter, those are the solids. On the right, it's about 50-50 in most soils between solids and nothing, right? It's not nothing, but airspace, pore space that fills up with water. And when you get a rain event and it goes all the way full, it forces all of that air out. Why that matters, we talked about photosynthesis, plants taking in carbon dioxide, bringing out oxygen. Yeah, the leaves in the light, but the entire plant also still needs oxygen to respire, just like you and I do. And there's no photosynthesis happening in the roots. So those roots get their oxygen from those pore spaces in the soil. This is why you need some larger pores that will hold water, but only for so long. The bigger the pore space, the more water it can hold in a rain event, but also it will not, that water is clinging to the edges of that pore, and the middle of it will eventually drain out and create an airspace. So a larger pore space allows for better oxygenation and aeration of the soil, which is absolutely critical when we have rain and rain and rain and rain. So here's a plant. I'm saving a lot of this for like disease. That's another session, right, in this series. But when you have plants suffer, if you put a transplant in the soil and it's buried deep, or it stays wet and it just stays too wet, yes, those conditions might be good for disease, but also at the same time, the other huge factor is if there's not enough oxygen in the roots, they are struggling, you get dead roots, the disease can go crazy. So it is a big plant health factor. If maybe you've already figured out your soil texture, right? But if you haven't, you can also just kind of, what is your soil's drainage like? Dig a hole, fill it to the top with water, let it drain, fill it again. How long does it take for that to drain completely? If it's within a few hours, you've got a nice sandy soil. If it's, 4 to 6 hours, it's probably going to be fine, but maybe you can work on soil health and improve that. If it takes more than 8 hours, you probably are going to have a hard time, and you might need to supplement that soil. You might need to think of raised beds or things like that. And this is all normal gardening, right? Normal soil questions, but it's just that much more important when we have increased precipitation events, number of them, frequency, and also like actual quantities of precipitation. So, okay, too much water. This is back to that idea of the pore space. If you have a well-structured soil, if you could imagine water clinging to the edges of all these aggregates, you could see why this large pore is going to empty out of water first, because that water, like when it clings to the inside of a glass, it'll only go so high up that the wall of a glass. But if you have a straw, it can kind of cling higher up to that above the surface of the water. because it's just more surface tension and more adhesion. Um, so these bigger pores are not able to hold the water as strongly, and it drains a little bit better and can get into lower areas. So my same garden space later that same year, more than a 2-inch rain event. And yeah, I've got a little bit of ponding there. I had not yet fixed the overflow going into that area. But what are the few things that maybe stand out here? I've mulched my tomatoes. That area is going to infiltrate that water, so it's less likely to run off. You can also see I have added height. And this is probably the number one thing you can do if you're disturbing your soil, like a raised bed of some sort. Because now the lower spots are where the water can drain to. I have a soil that will drain, and I have good enough soil health that those channels exist so the water can get through it. And that area that the plants are mostly rooted in is up above where it's draining to. So you want that soil high and dry if you can, provided you can add water to it. I will add water whenever I need to, right? This is, in thinking of for farmers, but this is also true for our own gardens. You have to be kind of thinking like an engineer a little bit. If you have a structure and you want to grow in it, like a high tunnel like this, you still want it to be, even though it's going to be covered from rain coming in, you need it to be up above where other areas are going to be. For somebody who's going to be growing in the winter, this field is maybe going to flood occasionally all winter long. Similarly, your garden, you want to think about how does water flow in the landscape, because it won't always infiltrate. There's always going to be some runoff, but especially in those big events, there's going to be more runoff happening. So where does it go from? Where does it come from? Where does it go to? And where are you trying to grow in that? Can you slow it? Can you use that to your advantage? Maybe install a rain garden specifically. So this picture is to help remind me of what the next little bit is here, talking about soil fertility. I'm going to try to wrap it up. This is from a research study I did in grad school, and this is a very sandy soil, and this is a very nitrogen-hungry crop, and you can see that there is a big green circle right in the middle of this research plot. You don't want that for research. The reason that happened was this very, very sandy site had overhead sprinkler irrigation, and they would be putting out a circle of water, and this was the one spot where those circles did not overlap. So this spot stayed drier, which means that it didn't lose nitrogen fertility that had been applied. So how do you lose nitrogen fertility that was applied? This 2023 was the year where folks maybe did add fertilizer and they maybe had their soil fertility just right, but there was so much rain that a lot of folks' crops or gardens became nutrient deficient. So we'll focus on nitrogen because it's tricky in general. It's also really important. Um, this is sort of like I know it doesn't look simplified, but this is a simplified nitrogen schematic for how things change in your soil. The main thing to think of is you're mostly applying organic nitrogen right there in the middle. It needs to get broken down by microbes into ammonium. Those microbes then transform it into nitrate. And the nitrate is usually what your plants are taking up, but it's also where you can lose nitrogen, both through leaching and denitrification. So we'll talk about leaching first. Really quickly, your clay, one of the reasons we love clay in our soil, at least a little bit, also why we love organic matter, is something called CEC, cation exchange content. This is a topic for another story. Sorry, a story for another discussion. But basically, how negatively charged your soil particles are. Most of our nutrients are positively charged. So calcium, potassium, magnesium, all sticking well on that soil with really high cation exchange content. Soil with lower cation exchange content, less sites for it to bond like a magnet, right? Opposites attract, negative and positive charges. When you have nitrate, it's negatively charged. And so it's not going to like just stick to the soil. So that means it is sort of free floating in the soil solution, in the water in our soil. When you have a ton of water coming through your soil, anything that's free floating in it is going with it down into the subsoil where you're probably not going to see it again. So that's one reason why these really high rain seasons can take your nitrogen that you have already applied or that's been broken down from your compost, your organic matter in the soil, and you can lose it. The other is denitrification. And that is, I don't have any other slides to go into it, but basically you deprive the microbes in the soil of oxygen and they will start using nitrate instead of oxygen for their processes. And that will result in some sort of nitrogen gases going up into the atmosphere. Sometimes they're even bad greenhouse gases. So you don't want that to happen in general for multiple reasons. So leaching can happen just even if your soil never goes anaerobic. You just get lots and lots of rain. You can lose nitrogen that way. You can also lose some of the other nutrients, but not as severely as nitrogen. If your soil goes anaerobic and there's not enough space for oxygen because it's not draining well, and it's just sitting with those pores full of water, A, that's bad because there's no oxygen for the plant roots, but B, there's no oxygen for the microbes, so they start using nitrate and getting rid of it. Um, so again, this is why I wanted to make this about soil health, right? Why does soil texture matter? Why does soil drainage matter? And as nitrogen gets broken down from organic matter, fertilizer, whatever you're adding as your source of fertility, it is a microbial process. So you need warmth, oxygen, enough moisture, but not too much, and you will get things breaking down, releasing nitrogen that's available to plants. And this is the expectation in a normal year. Uh, in a wet year, you maybe have significant leaching and denitrification. And so then, that's a big gap relative to what you were expecting in that wet year versus your normal year. When you think about your plant's cumulative need over time, the gap between your normal year and your plant's total need is like how much you could add a little extra fertility to make it just perfect and get your great crop yield. In a bad year, you need a lot more. And so this is why on the farm scale, there are some soil tests that can be done. Um, but in the home scale, it's sufficient to just know if it's been really wet for a long time and cold, you probably don't have the nitrogen available to your plants that you think you do. And my last like couple wrap ups, right? So your soil health losses can accumulate on your left. You want good soil structure. You want good aggregates. Um, it's porous. It drains well. Um, on the right is what happens when things go bad. Those aggregates are smaller. They're packed together. They're compacted a bit. There's a crust on the top that is limiting water getting in. It's also limiting air exchange, which can help to dry the soil and is just good for good oxygen in the soil. Then we have sort of compaction because maybe somebody worked the soil while it was wet, etc. These things can kind of compound and get worse over time. So to avoid this, we want to maximize our soil cover whenever we can. Living roots. We want living roots. We want to build our organic matter to feed the soil so that you have good, healthy soil structure. And you want to reduce your disturbance whenever you can. Um, tillage is not, I don't mind if you till. I think that's fine. I till, but you don't want to go crazy and you want to be careful about when you're doing it. And if you can reduce it, then it's almost always going to be a good thing. Okay, there we go.
Thanks so much, Caleb. And thank you, as folks have noted in the chat, for being down to bear with us even in illness. We appreciate you. Um, try to go quick through some of the questions that came in, and you just started to speak to the first one, which is about no-till farming or gardening. And can you say a little bit more about what that is and how it might be beneficial?
Sure. So there are lots of different versions, and a lot of people start to get into like no-till tillage. More and more, even some of our farmers who are really committed to it are talking more about the spectrum, where, are you really heavy tillage or are you reduced tillage to no tillage maybe? Um, and so. Uh, Conventionally, it has been done where they'll spray with herbicide. Maybe they'll grow a nice cover crop, spray it with herbicide, and then have heavy equipment that can plant into that, and their crop can grow through it. There are soil. The reason it's done is for soil health benefits. There are good soil health benefits from that, even even with the herbicide approach. We have a lot of farmers who don't are organic and either aren't allowed to use those tools or don't want to. And so there's a lot of other approaches people have taken on. One is called deep compost mulch, where they'll put in a thick layer of compost. It doesn't have to be compost, but that's what most people have settled on. The idea is a deep mulch that your plants can grow in, but also that you are adding height to your bed, getting that drainage effect, but you're also you're blocking weeds. So the weed seeds that are in your soil can't get through. And you have to maintain it because if you're not going to till it, if you're not going to disturb it, you have to make sure that absolutely no weeds are allowed to set seeds. Otherwise, I mean, the weeding gets to be the point where you can't control it just by hand weeding anymore. So it means really critical uh, attention to weeds. The other tool a lot of people use are tarps, which are silage tarps. It's agricultural plastic, so it's UV stable, and they'll drag it out over a growing area, kill what's there, and that helps to prepare the soil. Um, there are some pitfalls at times, and it's hard to go from a tillage system to no-till immediately. There's often people can see some hiccups along the way. So in the home garden, I recommend people consider like how much tillage are you actually doing anyway? Maybe you could start to just use a broad fork instead of a rototiller. You can still loosen the soil without disturbing the soil life as much, without breaking up that soil health quite as much. Um, yeah, it's a topic of its own. It gets a lot of people have a lot to say about it.
Thanks, Caleb. Um, and then two related questions. Why does a simple layer of mulch slow soil infiltration? And then another asker wonders why green mulch and ground cover plants aren't always considered more of a solution for growing crops and climate change.
So the simple layer of mulch, it's simply slowing the movement of water. So uh, unless you have an absolutely laser leveled growing surface, the water that doesn't infiltrate immediately is going to start moving in one direction or another. And so physically slowing that, as well as you do less damage to the soil, you're less likely to get that crust layer on the surface of a soil if you have a mulch over top of it, because that will, a big heavy raindrop coming that far that fast brings a fair amount of energy with it, more than we sometimes give them credit. And so if you can disperse that energy and then physically slow the movement of the water, it gives it time to infiltrate, and you also prevent the soil from crusting over quite the same way. The other question was about green mulch ground cover plants not considered more of a solution. Um, so the one of the number one ways where we talk about reducing the climate impacts of agriculture is just more cover cropping. It's consistently the least expensive and one of the most impactful for adding carbon to the soil, reducing a lot of the harms. And most farms want to do more of it. A lot of gardeners want to do more of it. But for the farm scale, it can come down to at least perception of like how much is it going to cost, and do I have time to squeeze it in a growing season. This is one of the funny bright spots with climate change, is that I've got more farmers that I see putting cover crops in later in the season and getting better growth out of them than we ever used to previously, just because this fall is staying warm for so much longer.